Welcome you all students. In this video lecture, I will give you brief introduction about system of force. System of forces. By the way, what do you mean by force? Force is actually defined as action in the form of push or pull exerted by the body on another body. So when you are applying the force on any object, what happens? The object will move in the direction of the applied force. So here it is system of force. System of force in the sense I can say several number of force acts simultaneously on an object, then they are called as system of force. Several number of force acts simultaneously on an object, then they are called as system of force. Okay, the system of force is actually classified namely into two. One is coplanar force, and the another one is non-coplanar force. Okay, so this coplanar force, what do you mean by coplanar force? Coplanar force in the sense set of various external force acting in the same plane. Then it is called as coplanar force. Non-coplanar in the sense set of various forces, external forces acting in different planes, not in a same plane, it's acting in the different planes. Such kind of forces comes under non-coplanar force. So when we look into the coplanar force, actually this coplanar force is divided into some divisions. First one is concurrent force, and the second one is parallel force, and the third one is collinear force, and the last one is non-concurrent force and non-parallel force. Non-concurrent and non-parallel force. Okay, so when you come to the non-coplanar force, just like this coplanar force, here as well we have divisions. The first one is concurrent force, non-coplanar concurrent force, and the second one is non-coplanar parallel force, and the third one is non-coplanar concurrent force and non-coplanar non-parallel force. Non-coplanar concurrent force and non-parallel force. Okay, let's see about the concurrent force first. Concurrent force, that means coplanar concurrent force. Coplanar concurrent force. So concurrent force in the sense, we know coplanar in the sense it's acting on the same plane, right? So I'm going to take the axis or force to fall on the same plane. Okay, so I have taken one plane. So here I can say set of all the various external forces acting on or line of action passes through the points. Okay, that means if I consider a point, all the forces on a system just act on the point or passes through the line of action. The line of action passes through the point. So this kind of force system we call it as concurrent force. All the forces acting on the point or the line of action passes through the same point. I can give an example for this concurrent force so that you will be getting more familiar towards this understanding of this concurrent force. Okay, so best example for this concurrent force is stress. When you are roofing the sheets metal works, okay, so in order to give the support to the roof, they used to have the structure which is called truss. You can see the arrangement something like this. If you see at a particular point, all the forces will be tensile or a compressive force, but it will be a order concurrent. That means all the line of action of all the forces act on the same point. So best example for the concurrent force is stress. And the second one and the coplanar parallel force. Coplanar parallel force. So coplanar parallel force. So parallel, am I right? So if I take the arrangements of a single plane, it's a coplan, so single plane. All the or set of various forces or external forces whose line of actions are just parallel to each other. What are the forces acting on the system will be parallel to each other and in the single plane. Such kind of force system we can call it as what? The parallel force. See, look at this diagram. All the forces like F1, F2, F3 which are just moving in parallel direction. Am I right? So here in the parallel force, two kind of parallel force can be possible. One is a like force and another one is a unlike parallel force. Like force, if it is a like force, what happens? In a single plane, forces arrangements will be just directed in the same path. That means if the forces are moving F1, F2, F3, F4, each line of action movement will be located to unique direction. All the forces will what? Directed to the unique directions. Okay, something like this. If it is unlike parallel force, then the line of actions or direction of force will be irregular, maybe up and down, something like this. So this we can call it as unlike parallel force. Okay, so here in the parallel force, I can say the best example as beam and column. Beam and column. So here I am going to show it. Beam and column. It is 4 parallel forces. See, this is the beam. I am going to support this beam by column, something like this. So this is how the arrangements is done for beam and column. So when I apply the force on the beam, something like this, which is parallel and acting towards what? The same direction. Am I right? So this arrangement I can call it as like parallel force. If the forces on the beam and column is, that means here it is considered the force is acting in the downwards. Am I right? So here since the supports are done, that means the columns are supported, what generally occurs is there will be a reaction, just it will be opposite in direction, something like this. So if you consider the reaction, then the system, what is happening? We are having the downward force as well the upward force. So this system we can call it as unlike parallel forces. So forces on the beam and column is the best example for parallel force. And the third one is the collinear force, coplanar collinear force. Collinear force, coplanar collinear force. So it is forces all going to act on a single plane. I can say a set of various external forces whose line of action is in the same line. Okay, so that means if I show the diagram, something like this, a single plane, all the forces F1, F2, F3, which is just passing in the same line. All the line of actions of F1, F2, F3 are passing through the same line. It can be inclined line, it can be a horizontal manner, the line of action can be go just like a vertical manner, anything, but it will be moving in the same line. Okay, such kind of things we can call it as collinear. Same like parallel forces, here as well we are having like collinear forces as well unlike collinear force. So if I call the system as like collinear force, then all the forces should directed in the same direction. If it is F1, F2, F3, F4, all should directed to the same direction. If it is unlike collinear force, then all the forces are not at all directed in the same direction. It can be left or right, it will be in an irregular manner, but it moves in the same line, but the direction may be differ, right? Such kind of system we can call it as unlike collinear force. So for example of collinear, especially like collinear force, I can say the train. See the train arrangements. You can also see the engine in the rear side as well the front side. Am I right? So there will be lot of compartments, something like this. So when the train is moving, the movement will be in the direction something like this. So what happens? Each and every compartment will be connected one another, right? So when the engine is moving in the forward, all the compartments will be moving in the same direction, and the line of action of each and every forces acting on the train will be in the same line. Okay, so this is the best example. Train is the best example for like collinear forces. And when we come to the unlike collinear force, best example I can say as tug of war. See, in the tug of war, set of peoples will be pulling the rope. Am I right? So some of the set of people will be pulling the rope, something like this, and in the opposite side, team will be just pulling the object, something like this. Am I right? So forces acting on the rope is the best example for what? Unlike collinear forces, right? So let's move to the last one, and the coplanar force, which is non-concurrent force and non-parallel force. Non-concurrent and non-parallel force. Non-concurrent and non-parallel. So non-concurrent and non-parallel force in the sense a set of various force, external force, whose line of action is neither parallel nor intersecting at the same point or meeting at the same point. Such kind of force system we call it as a non-concurrent or non-parallel. So for example, I can show the picture x, y. So it is acting in the single plane since it is a coplanar. All the forces F1, F2 or F3, which are not at all making order, meeting on the point or parallel to each other, something like that. In the irregular manner we are having the force arrangements. Okay, so such kind of things is non-concurrent or non-parallel force. Best example for this particular topic is ladder. Forces acting on the ladder. Okay, so that means we know ladder. So there is a wall horizontal, it's a ground and it's a wall. I'm going to just keep it against the wall, something like this. I'm just keeping like this against the wall. So obviously the weight of the ladder will be just coming downwards. Okay, and since it is just kept something like this, what happens, just ladder tries to move. That means the movement will be something like this, so that in the ground the friction force will be acting something like this. And as far as here concerns, when it is sliding, what happens, the movement of the ladder will be downwards. So here as well the friction force will be acting, which will be just moving up. If I take this as 1, we can give this as 2. And in the contact areas there will be what, reaction, particularly here as well there will be a reaction force. So in this system no force is what, parallel or meeting at the same point. So I'm saying this is the best example for what, the non-concurrent or non-parallel forces on the ladder. And the next one, non-coplanar forces. So there we have 3 concurrent, parallel and non-concurrent forces and non-parallel forces. First we can begin with the concurrent force. Concurrent force. So it's a non-coplanar. So we are familiar, non-coplanar in the sense set of force acting on a body which are not in a single plane. Am I right? In a single plane, not in a single plane. So that means it is acting on each and every dimensions. Concurrent we know meeting on a particular point. So here in this force system, all the force will be acting something like this. From this plane, here it is going. From this plane, here it is coming. So if I take F1, F2, F3 and F4, the arrangements will be something like this. So what is the definition for the concurrent force? A set of various external force that acting or the line of action is passing through the same point or acting on the point, right? So here see, the line of action is just passing through the point and as well it is on the point. So this is how the force system will be. So for this concurrent force example, I can say tripod, camera tripod. So this will be something like this. So you are familiar with the tripod. So each force will be directed to a particular point from 3 dimensions. So it is the best example, the camera tripod is the best example for concurrent force and the non-coplanar force system. So the second one, non-coplanar parallel force. So here it acts in different plane, not in a single plane. It acts almost in every plane, but set of external force acting on the body will be the line of action will be parallel to each other. If I consider this as F1, F2, F3, all the forces are just parallel to each other. So this kind of force we can call it as parallel force. The example for this non-coplanar parallel force, I can say slab and column. Slab and column. Slab and column. So three-dimensional manner I gonna draw so that you will get some idea regarding what I try to say. Okay. So above the column, above the slab, I'm gonna keep the column. I'm gonna keep on each and every corners. So in the four corners, I'm gonna keep the what? The column. So this is how the things will be. This is how the things will be. So do it like this. So here, when the column is placed over the slab, the force acting from the column to the slab will be something like this. So force acting on the slab and column is the best example for what? Parallel force. And the next one is the last one, non-concurrent force and non-parallel force in the non-coplanar force system. Non-concurrent and non-parallel force. Non-concurrent and non-parallel force. See, here all the forces acting on the body, set of various external force acting on the body whose line of actions are neither parallel nor acting on the same point. So the arrangements will be something like this in an irregular manner. In irregular manner, if I take this as F1, F2, F3, it is not odd. It is not making parallel, and also it is not making odd. Just all the forces are not intersecting at a particular point. Such kind of things are called as non-concurrent or non-parallel forces. For this, I can give an example: forces on the bus. Forces on the bus. Just for your better understanding, just think this is the road surface. So about that, the bus is gonna drive. So this is how the bus is. Okay. It is just moving forward. This is the motion of the bus. So what are the forces are possible here? Since the wheel is just having contact at the road, there will be a reaction, R1, R2, something like this. And since the motion of the particular bus is just moving in a forward direction, definitely there will be a friction force on each and every wheels that will be directed opposite side to the motion, something like this. And there will be air resistance when it is moving forward. There will be air resistance which will be just having opposite against the bus. As well, the weight of the bus will be acting just downwards. Okay, so here see all the forces arrangements, or when you are viewing it in the three-dimensional view, all the force just acting on the bus is not parallel, as well it is not concurrent. That means not meeting at a particular point or at a particular intersecting at a particular point. So such kind of force system we call it as non-concurrent and non-parallel force. So I hope you understood about the force system. What are the subdivisions are coming under the force system, and what are the thing exactly. Okay, I hope you understood what exactly it is given. Thank you so much.